Hello everyone, in this video we will go over the solutions to midterm review number 1. So let's start with the first question, which is asking you just to find the area enclosed by two functions. So the first thing you should do is graph the two functions. When you get the graph the two functions, it looks something like this. You need to find actually first the points where the two graphs intersect so you can find the limits of integration. And that's basic algebra. Just set the two equations equals to each other, so 2 minus x squared should equals to minus x, which implies x squared minus x minus 2 has to be 0. Then just factor this. You can also use a quadratic equation, but that would be too much. It's a lot easier to just factor. So the two solutions are 2 and -1, which corresponds to this one, this one. The area you're trying to find is the green area. So by definition, remember the area is going to be the integral from -1 to 2. Why? Because that's the 2 points where they intersect. The biggest function is this one. So this will be 2 minus x squared minus the smallest function. And then this is a very easy integral. If we integrate, you end up with the integral of 2 give you 2x. The integral of x squared, it will be x cubed over 3. Here minus and minus become plus. This will be x squared over 2. And then you plug in the limits of integration. In the time, due to time constraints, if you get this far, this is good enough. But if you plug in the values of integration, you'll end up with 4 minus a over 3, this should be minus, plus 4 over 2, and then you plug in the negative, so it'll give you -2 minus my 1/3 q, the 3 goes just on the top, plus 1/2, and once all of this is simplified, you will end up with 9 over 2. Okay, that's it for that one. Part B is very similar. The first thing you have to do again is to do the two graphs. And remember, in the test you are allowed to use a graphing calculator, so you can use it. But the most important thing of the graph, or the point of the graph, is to be able to see two things: which one is the biggest graph, and more importantly, what are the limits of integration. So the graph should look like this. So algebraically, we had to find the intersection. Remember, the intersection is to figure out the limits of integration again. Here you just had to set the two equations equals to each other. This implies you have 2x squared equals to 4. And from here that means that x is equals to plus or minus square root of 2. That's why we got this. You can see this is the biggest function, this is the smallest, and this is the area you want. Okay, then just like part A, this is the integral. This is from negative radical 2 to radical 2. This is 4 minus x squared minus x squared. The x, this is the integral from minus radical 2 to radical 2. 4 minus 2x squared, the x. The integral of this will give you 4x minus 2x cubed over 3. And remember, you're supposed to plug in these values. Again, on the test, you get this far, this is enough. If you plug it in, this will be 4 radical 2 minus 2 radical 2 cubed over 3, all of this minus the negative version of this is negative, and then just simplify, or you can use a calculator, so whatever that is. Okay, that's it for that one. Okay, and question number 2, you need to find the volume of the two functions if you revolve it around the x-axis. So again, first you need to graph the two functions. This is x squared plus 1, and you can use the graphing calculator to do this. This is the second line, y equals to minus x plus 3. And the area trying to revolve is this one right here, and you want to go around the y-axis. To find the intersections, which we already have there, again, remember all you have to do is set the two equations equals to each other. So the intersection, in case you don't have the graph, is x squared plus 1 equals to minus x plus 3. This gives you x squared plus x minus 2 equals to 0. Then you factor this, and it gives you the two values that we already have, minus 2 and 1. Okay, so for the volume, which is why you care, is the integral from negative 2 to 1 of pi, and then the biggest function, which in this case is minus x plus 3 squared, minus the smallest function, which is this square. Okay, then do some algebra here, so this tribute, and you will end up with pi in here. This will give you 9 minus 6x plus x squared minus x to the 4 plus 2x squared plus 1, this x squared dx. Then combine like terms, and you end up with 8 minus 6x minus x squared minus x to the 4 dx. And if we integrate this, you end up with pi ax minus x squared over 2 minus x cubed over 3 and minus x to the 5th over 5. The limits are minus 2 to 1, and then whatever is that. Okay, in this question, it's very similar to the previous one, and you can use either of the two methods. This is the function y equals to 3x minus x squared, and you want to revolve this around the line x equals to negative 1, which is this one right here. So this keeps going, but we only care about the shaded area. So we need to find the distance between the partition and the axis of revolution. So the distance from here to here is 1, and the distance from here to here is x. So therefore the total distance is x plus 1. So then the formula, remember, is the integral from 0 to 3 of 2 pi, and then the distance, which is x plus 1. You can also find this by doing this, x minus 1, but I just show you right now how the answer is x plus 1. Okay, then we have the function 3x minus x squared dx, and if you distribute, you end up with something like this: 3x squared minus x cubed plus 3x minus x squared dx. This simplifies to 2 pi, you can put it outside, and then this is 2x squared plus x 3x minus x cubed, and then just integrate. So the integral of this, it will give you 2x cubed over 3 plus 3x squared over 2 minus x to the 4 over 4 from 0 to 3. And when you plug the limits of integration, the answer is going to be 45 pi over 2. Again, if you get this far for the test, you can stop there. Okay, that's it for that. Okay, question number 3. This is very similar to one of the questions we have in problem of the week. Actually, it's the same question. The only difference is the limits of integration are going to be different. But let's do the whole problem again. So first, you need y prime, and this is 1/2 e to the x minus e to the minus x. You're going to need also y prime square, and when you FOIL this, this is what I mean. You need to FOIL this, and when you do and take into account that e to the minus x times e to the x is equals to e to the 0, which is 1, we will end up with something like this. Okay, you should try this. If not, look to the solution of, I think was problem of the week number 2, where I do this. Okay, okay, now remember the formula for the arc length requires 1 plus y prime squared. So therefore, if you add 1 to this, which is the y prime squared, 1 minus 1 gives you 1/2. So you end up pretty much with the same thing, except that instead of minus 1/2, it will be 1/2. And that's pretty good news. By the way, there is a mistake here. There should be 4. That's pretty good news because that means you can factor this as a perfect square. So therefore, this is 1/2 e to the x plus e to the minus x whole thing squared. Alright, now recall that the arc length formula is the integral from a to b, which in this case is from 0 to 2, or the square root of 1 plus y prime squared. Well, we already compute all of this with all the work, and if you take the square root of this, the squares cancel, so then this is the integral from 0 to 2 of just 1/2 e to the x plus e to the minus x dx. And then the integral of that will be 1/2 e to the x minus e to the minus x from 0 to 2. So this will give you 1/2 e squared minus e to the negative 2 minus e to the 0 minus e to the 0. These two will cancel, so this will be 1/2 times e squared minus 1 over e squared, and whatever that is. Okay, in part B, we also need to find the arc length. So first we need y prime. So y prime, remember, is the derivative with respect to x of secant x divided by secant. That's the definition of the derivative of ln. So from here you get y prime is equals to secant x tangent x, which is this, okay, divided by secant. So these two cancel, so this gives you just tangent theta. Okay. So then you need 1 plus y prime squared, so that will be 1 plus tangent square. Remember, there is an identity for this. 1 plus tangent theta is just equals to secant square theta. So hence, the arc length will be the integral from 0 to pi over 4 or the square root of 1 plus y prime square, which is the integral from 0 to pi over 4 of just secant square. Well, the secant square and the secant, they cancel. And the radical they cancel, so this is just the integral from 0 to pi over 4 of secant x dx. This is actually equal to the absolute value of secant x, this part. But since x is positive, you only use the positive side. There's no need for absolute value. Then, remember that the integral of secant is ln secant plus tangent. And then if we pack the limits of integration, this would be ln secant of pi over 4 plus tangent of pi over 4 minus ln of secant of 0 plus tangent of 0. Well, this is equals to radical 2. Tangent of pi over 4 is 1. Then this is ln of 1, because secant of 0 is 1. Tangent of 0 is 0. But remember that ln of 1 is equals to 0. So therefore this disappears. So this is the answer. Okay, question number 4 requires that you do several techniques to integrate the problem, but the basis, the one you have to start with, it should be integration by parts. So therefore here u should be sine inverse, which means the u will be 1 over 1 minus x squared dx, and dv will be x, which implies that b will be x squared over 2. Remember, the integration by parts formula is uv minus b du. Okay, so if we apply that formula, it's going to call this I, that's the integral we're trying to find. Then I would be u times b, it will be x squared over 2 sine inverse x minus b, so 1/2 x squared over 1 minus x squared dx. Okay, here partial fractions doesn't work, and that was one of the problem of the week questions too. Then it was number 4. So you had to use a trig substitution. So let's call this one, this part only, I don't know, t. So t is the integral of x squared over 1 minus x squared radical dx. So I told you need a trig substitution, so let x equals to sine theta, so that implies the x is equals to cosine theta d theta. Okay, so then from here we end up with sine squared theta over 1 minus sine squared theta times the x, but the x is cosine theta d theta. Okay, notice here how this will cancel this y, because 1 minus sine squared is cosine squared, and the square root of cosine squared is cosine, so they two cancel. So this just leave you with sine squared theta d theta. Now recall, and you have this in the formula sheet, that sine squared theta is the same thing as 1 minus cosine 2 theta over 2. That's the double angle formula. So therefore, this is the same thing as the integral of 1/2 1 minus cosine 2 theta d theta. So therefore, this is 1/2. The integral of 1 is theta, and the integral of cosine 2 theta is 1/2 sine 2 theta. Okay. Plus c. Notice here that using another identity, sine 2 theta is the same thing as 2 cosine theta sine theta. So therefore, if you use that in here, the 2's will cancel, and you will end up with 1/2 theta minus sine theta cosine theta. And the reason why you have to change it to theta is because you don't have the answers in terms of 2 theta, only in terms of theta. Now to figure out the change from theta to x, remember you have to make a triangle. If this is theta, this has to be x, and this has to be 1 y, because sine of x, remember the substitution was that sine of theta is equals to x. So therefore this will be 1 minus x squared. So the answer to this part will be 1/2 theta, or theta will be sine inverse x. Sine theta, remember it was just x, and cosine theta is 1 minus x squared. Well, this divided by 1 plus c. So then the answer to the integral, it will be x squared over 2 sine inverse x minus 1/2 t. Remember, all of this was t, and plus c. That's it. This is actually the part B is a lot easier and faster than part A. This one just requires a substitution. So here, let u to be a sine, ln of sine. So that means the u is the derivative of sine, which is cosine over itself. But remember that cosine over sine is nothing but cotangent. So then from here, this is just the integral of u du. Okay, notice that this plus this together is the du. Okay. And what's the integral of u? This is just u squared over 2 plus c. So this will give you ln of sine x squared over 2 plus c. Now, is this the only way to do the problem? No. You can also do the substitution of u equals to sine x, but that's going to be way more messy. This is probably the fastest way to do this. For part C, you're gonna have to use the substitution either u is equals to tangent or u equals to secant. And in this case, the substitution is going to be u equals to secant, and the reason why is since you have a q for secant q, you won't be able to have a secant square to change it into tangent, And the identity we're going to use here, well, one of many, is this, which we use already in the previous problems. So this is what I want to do. This is the same thing as tangent to the 4 of 4x times secant square of 4x times secant 4x times tangent 4x. So in essence, we just borrow a tangent from here, and a secant from here to end up with this. Why do we need this? Because if we pick, remember, u equals to secant theta, then the u is secant tangent the theta. So therefore the goal is going to be to change everything into secant. If we use this identity, 1 plus tangent square is equal to secant square, which means the tangent square from here is equals to secant square minus 1. So we use that identity here. Instead of tangent to the 4x, we're going to use secant square for x minus 1 square times secant square of 4x times secant 4x tangent 4x, and remember this is going to be the du. Now before we actually made a substitution, because of the 4x, we need to get rid of that. So let's say that w is equals to 4x. So then the w is 4 the x. So that will change this into the integral of secant square w minus 1 square secant square w times secant w tangent w. This is just so that we don't have to worry about the 4 in there, and then this will be divided by 1 4. Okay, all right, so then this will be 1 4, and if you do the substitution to be secant, then we will end up with, if u is secant w, then this will be the integral of u square minus u square times u square du. And then this is just algebra. If you distribute this will give you 1 4, and this will give you the integral of, okay, we don't need this right now. This will be 1 4. This will be u to the 6 minus 2 u to the 4 plus u square. Once you distribute all of this, I'll give you this, the u. And then this is 1 4, the integral of u to the 7 over 7 minus 2 u to the 5th over 5 plus u cubed over 3 plus c. Okay, so now notice that u was secant, so this will be 1 4 secant to the 7 w over 7 plus minus plus plus, okay, it should be minus, sorry, 2 secant to the fifth w over phi plus secant q w over 3, all of this plus c. Then finally, remember w was 4x, so this will be secant to the 7 of 4x over 7, 2 over 5 secant 4x, and finally this, so you just replace w for 4x, and all of this is plus c. And that's it. Okay, in this integral, the degree of the top and the bottom are the same, so you cannot do partial fractions if the 2 degrees, if this one and this one are the same. So therefore you have to do long division first, or synthetic division, but long division will be the most appropriate one. So this is x cubed minus x squared, and inside you have x cubed plus 0x squared plus 0x plus 1. So this goes into this once. This will give you x cubed minus x squared plus 0x plus 0. Then remember you have to change the signs. So this will give you x squared, because minus and minus becomes plus 0x plus 1. So then finding this integral, okay, it will be the same thing as the integral of 1 dx plus the integral of x squared plus 1 over x cubed minus x squared dx. Right, so then you have to use partial fractions in here. This can be factored as x squared times x minus 1. So then the partial fractions are going to be a over x plus b over x squared plus c over x minus 1, and this should equals to x squared plus 1 over x cubed minus x squared. Okay, so from here, this give you ax x minus 1 plus b x minus 1 plus c x squared equals to x squared plus 1. If you compare the coefficients, like if x equals to 1, if x equals to 1, this will be 0, this will be 0, so that means c will give you 2. So from here c will be 2. Why? Because if this is 1, this is gone, this is gone, this will give you c times 1 is 1, 1 plus 1 is 2. Then you use the trick, okay, well, what about if x is equals to 0? If x is 0, then this is gone, this is gone, so you're going to have minus b will be equals to 1, which means b is negative 1. Then the last equation you get is that a plus c has to give you 1, but you already know that c is 2. That means that a is negative 1. So then let's call this again t, and the first integral is easy. This is just x, so all you have to figure out now is what is t. So then t is going to be the integral of minus 1 over x minus 1 over x squared, and finally plus 2 over x minus 1 dx. Okay, this just comes from here. A, b, and c, these are the values we found. So from here you will end up with all of this. Alright, so this is pretty easy to integrate. The integral of the first one is minus ln of x. The second one is plus 1 over x. And then finally this is 2 ln of x minus 1 plus c. Okay, so then the final answer to I will be x minus ln x plus 1 over x plus 2 ln x minus 1 plus c. Now this is good enough, you get this far, but you can combine the ln's and the properties of ln to write the answer like this: x plus 1 over x, and then plus ln of x minus 1 squared over x. Okay, but this should be written in this way. This should be like this. Ln of x in here is x minus 1 squared plus c. Okay, in question E, you have to use integration by parts, and here it doesn't really matter which one is doing the B, but I'm gonna pick U to be sine 3x, so that means the U is 3 cosine 3x, and dB is e to the 2x, so that means B is 1/2 e to the 2x. You're gonna have to do substitution by parts twice, integration by parts twice. So let's call this I again. So I, if we do integration by parts, is equals to 1/2 e to the 2x sine 3x, which is uv, minus b the u. Okay. So if we simplify this, we end up with minus 3 over 2 the integral of e to the 2x cosine 3x dx. Okay, now in this integral we're going to have to use integration by parts again. So let's do the same substitutions. U equals to cosine 3x, so that means the u is negative 3 sine 3x dx, and dv is e to the 2x, so v is 1/2 e to the 2x. Okay, so now let's just focus on the red area, and like before, let's just call this t. So then t will be 1/2 e to the 2x cosine 3x minus b, which will be 1/2 e to the 2x times du, which is minus 3 sine 3x dx. Alright, so this simplifies to this. The minus and the minus in here becomes plus, so you end up with plus 3/2 the integral of e to the 2x sine 3x dx. Okay, all right. So now, notice this is the key to the problem. This is what we have so far. From here, we have that I, which is what you're trying to find, is 1/2 e to the 2x sine 3x minus 3/2 t, but t was what? 1/2 e to the 2x cosine 3x, and then minus, it's actually, if you do this, okay, plus 3 over 2, but notice that this is the original integral, what we call I. So this is technically plus 3/2 I. Alright, so you do a more simplification, this will be 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x minus 9/4 I. Okay, remember we're trying to solve for I, so you have I here and I there. So you just have to combine it. If we do that, you're gonna have I times 1. If you move this to the right side, and it will be plus 9/4, and this will give you 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x. So therefore I will be all of this, I'm just going to call this A, divided by 4 plus 9 is 13, so this is 13 over 4, so it should be times 4/13. And that's it. Alright, part F can be done pretty easily if you remember a trick from pre-calculus. So here, notice the x squared is the same thing as x squared plus 1 minus 1. So therefore, you divide this by 1 plus x squared. This is the same thing as 1 plus x squared. It will give you 1. This is 1 minus 1 over 1 plus x squared. By the way, you can also get this using long division. It will give you the exact same thing using long division. So then from here, I is going to be the integral of 1 dx minus the integral of dx over 1 plus x squared. Well, the integral of 1 is just x, and the integral of dx over 1 plus x squared, remember, is tangent inverse x plus c. And that's it. Or you can also use a trig substitution where x will be tangent theta. This one will take a little longer, but this one will give you this. This should be tangent squared theta. If x equals to tangent theta, that means the x is equals to secant squared theta d theta. So on the bottom we have 1 plus tangent squared theta, which, remember, this is just secant squared. Now du or dx is secant squared theta d theta, so this will cancel, and then all you have to do is integrate tangent squared theta d theta, and then change to x, and it will give you the same answer as this one. Okay, so it's up to you. As long as the question doesn't specify, do this method. So if you have this question on the test or something like this, if it doesn't say how to do it, you can do it this way, you can do it this way. But if I say use trig substitution, then you have to do it this way. Okay. Okay, so finally, cosine to the 4th power. Notice that cosine to the 4th power is the same thing as cosine square. Okay. And you cannot use the reduction formulas on the test, so therefore you have to do it this way. Notice from one of the questions we did before too, that we have an identity, and the identity is cosine squared theta is 1 plus cosine 2 theta over 2. So you're going to have to use this identity twice. Now from here, then this means the cosine, the 4, is the same thing as 1 plus cosine 2 theta, 2x over 2 squared, which is equals to 4 on the bottom. It will be 1 plus 2 cosine 2 theta plus cosine square of 2 theta. So this simplifies to 1/4 plus 1/2 cosine 2 theta plus 1/4 cosine square 2 theta. Now this function is still a square, so we have to use this function again, or that identity. So then this will give you 1/4 plus 1/2 cosine 2 theta plus 1/4, and this, so we use the same identity, this one. This will give you now 1 plus cosine 4 theta, because this is 2 theta, over 2. And if you do algebra one more time, this is 1/4 plus 1/2 cosine 2 theta plus 1/8 plus 1/8 cosine 4 theta. So therefore, the integral we're trying to find, I, will be the integral of 1/4 plus 1/8 is 3/8. So this is 3/8. Plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. And then this is actually pretty easy to integrate. This will be 3/8 theta plus 1/2. The integral of cosine 2 theta is sine 2 theta over 2. And then the integral of cosine 2 theta is sine 4 theta over 4 plus c. Okay, so this is good enough for an answer. So the answer should be, the integral is 3/8, and this shouldn't be theta, by the way. This is actually should be x. So it should be x plus 1/4 sine 2x plus 1 over 32 sine 4x plus c. Okay, so remember that this, all of this should be x. This is x, x, x. Let's see what else. Yes, all of this should be x's. So just change that to x and x. And that's it. You can go a little farther on this one by using the double angle identity for sine 2 theta, but it's not required. But this is what I mean. This here is 3/8 x. Remember that sine 2 theta or 2x is the same thing as 2 sine x cosine x. So therefore this one will cancel the 4, so it will give you 1/2 sine x cosine x. And then you could in theory do the same thing for this one. This will give you 1 over 16 sine to x cosine to x plus c, but this is not necessary. Okay, if you get this far, this is good enough.